In this lesson, we're going to be comparing the values of a linear function and an exponential function. You can see the linear function over here and the exponential function going this way. And we're going to notice some patterns in linear and exponential functions when we're looking at a linear and an exponential function together. So let's note a couple of points on this graph. First is our point right over here, which is around x equals -1, and the y values for both graphs are very close to 0. And our next point that we want to look at is this one right over here, where the two graphs intersect again at approximately x equals 38 and y equals, we'll write this down, 38, and y probably equals about 158. So we had -1 and close to 0, and then 38 and 158. That is where our linear and exponential function equal each other. Let's look at the values of the functions before, in between, and after those points. So to the left of -1, our exponential function is decreasing. It reaches close to 0, it never goes below 0, but our linear function goes negative, negative, negative in the down direction on the y-axis. So in this case, when we're going past -1, left of -1 on the x-axis, our linear function is less than our exponential function in the negative direction. What happens between our points of intersection on this graph, between the 2 points where these functions meet? Well, our linear function over here at, let's say, about x equals 20, our linear function has a higher value than our exponential function. And so between these two, our linear function is greater than our exponential function. Does this stay true at all times? Nope. We can see as we increase and we go past our other points that they meet, our linear function at, let's say, about 50, x equals 50 up here, is going to have a lower a lower y value than our exponential function. So in the great increase of x, if x were to go on to infinity, our exponential function would eventually be greater than our linear function. And we're going to find that no matter what the two functions are, the value of an exponentially growing function will always outgrow the value of a linear function in the long run. You can see this in another quick example over here. Our linear function meets our exponential function over here, and it's greater than the exponential function at that value, but in the long run, our exponential function grows so much faster than the linear one does that it will have a higher value after the second point of equivalence for the two functions. So an exponential function will always outgrow and exceed the linear function eventually.